There are also some similar situations under the gravitational effect that we can observe in our daily situation, such as a tossed coin or water fountain. If we toss a coin in the air, it will move upward, but it gets slower and finally it stops at a certain point and then going downward. Now let's analyze the upward motion. As we toss the coin, it will have initial speed. Let's call it V0. So the same story also with the water. It also has V0. Now, due to the attraction by the gravity, the speed of this coin will become smaller and smaller because it decelerates 10 meters per second each second. And the speed for the upward motion finally will be 0 at the highest point here. So also the water at the maximum point, the speed will be 0 meters per second. Now, for example, if we shoot a ball vertically so that it has an initial speed 40 meters per second, so this is the beginning, or t is equal to 0. After 1 second, the speed here will be 30 meters per second. Why? Because every second the speed will be decreasing 10 meters per second. So at 2 seconds here, you can guess that the speed will be 20 meters per second. And then at 3 seconds, it will be 10. And finally, after 4 seconds, it will stop at the highest point here, or the speed is 0. And then it will fall downward. Now, if we plot the speed versus time graph for the upward motion of the ball, we will have, see here, for example, the initial speed is 40 and then 30 and 20, 10, 0. So if we connect these points, you will get a straight line like this. Look that every second the speed will decrease 10 meters per second. So in general, we can find that the motion which has an initial speed, let's say v0, and then it gets the gravitational acceleration, so after t seconds the speed will be v0 minus the gravitational acceleration g times t, where we have here g is 9.8, or we can also use 10 to simplify our calculation. Let us now see the downward motion after the ball gets the highest point. So let me remind you again that the initial speed here is 40 meters per second, and then after 1 second it will be 30, and then at 2 seconds it will be 20, and then after 3 seconds it will be 10, and after 4 seconds it will be at the highest point, so the speed is 0. So now after 1 second from the highest point, or we can say that the time here is 5 seconds, the ball will get the gravitational acceleration, so that will increase the speed by 10. So the speed here will be 10 meter per second, and then at 6 seconds or 2 seconds after the highest point, it will be 20. So, and then after 3 seconds from the highest point, or 7 seconds here, the speed will be 30. And finally, at 8 seconds, the speed will be 40 meter per second. So basically, the speed at the same position here, they are the same. Now, if we plot the speed versus time graph for the motion of this ball, we'll get, so this is the upward motion, and you already saw the graph like this, and then starting from the highest point at t is equal to 5, the speed is 10, and then at t 6, the speed is 20, and at t7 the speed is 30, and then 40. So basically, the speed versus time graph is just mirror graph like this. Now let us see the distance versus time graph for the upward motion. So here we have an initial speed of the ball, 40 meter per second, and then after 1 second the speed will be 30 meter per second. So you can calculate the distance traveled from the beginning here, 0 until 1 second, or in interval of 1 second. That the distance traveled will be 30 times 1 plus 40 times 1 divided by 2. So you get 35 meters here. And at t is equal to 2 seconds, the speed, as you already knew here, is 20. So that the distance in this interval time is 20 times the interval time here is 1 plus 30 times 1 divided by 2. So we get 25, and the total distance traveled is 25 plus 35, you get 60. And from 2 seconds until 3 seconds, now we have here the speed is 10, so that the distance traveled in this interval of time is 15. You get from 10 times 1 plus 20 times 1 divided by 2, so the total distance from the beginning here is 75, and then from 3 seconds until 4 seconds, or the time when it gets the highest point here, you know that the speed is 0, so the distance in this small here is 5 meters. So you get this point, and if we connect these points along its journey, we'll get a parabolic curve like this. Here we will discuss the distance versus time graph for the overall motion of the ball. As you saw previously, that for the upward motion, the distance versus time graph is like this. So now from the highest point, or t is equal to 4 seconds, and after 1 second here, or the time is 5, you know that the distance is also 5, since here the speed at this point is 10 meter per second. So 10 times 1 plus 0 times 1 divided by 2. So here, when the time is 5, it will get this point. And then from 5 seconds to 6 seconds, remember that the speed here is 20, so that it will move 15 meters in this interval of time. So this is another distance travel from 85 to 100. And then at 7, here the speed is 30, so it will move 25 from here to here, 25 meter. And then finally at 8 seconds, the speed here is 40 meter per second, so the distance travel here is 35. So from here to here is 35, and you get another parabolic curve. So at the moment we will limit our discussion at the distance versus time graph and speed versus time graph. Well, actually there will be another higher level of the discussion. There are the position versus time and the velocity versus time, but we will get into that sooner or later.